Hello, Algebra 2 people. So here we are going into, we're going to save 5-3 for when we come back from break. So we're going to focus on solving radical equations, which is actually hopefully maybe a nice breather from what you just did. 5-2 is the hardest section of the chapter. All right, so solving equations, you've already looked at some simple versions of this. So what we're going to look at are first the steps, because they're kind of uniform for all these problems. The first thing you always want to do is isolate the radical. Once that radical is, or fractional exponent, whichever way it comes to you, then when you have it isolated, you raise each side not to the same exponent, but to the reciprocal. So oh, that was good. I know how to spell reciprocal. I really do. Let me correct that. Reciprocal power. So if I have something cubed, I raise it to the 1/3 to cancel it out. If it's already 1/3, then I raise both sides to the cubed, to the third power. Once you have done that, you're going to solve the remaining equation. Realize sometimes you might have to go through this process several times, as you will see, but the most important thing is check your solutions, because in this process, when you raise something to a power, sometimes you create extraneous solutions that don't work in your original problem. All right. So let's start this off. Let's start off friendly. So we want to isolate our radical. So the first thing I'm going to do is divide by 2. And what that gives me is square root of x plus 1 equals 2. And since the square root, remember this has a little 2 in the nook, that's like a 1/2, I am going to just go ahead and square both sides. So x plus 1 equals 4. And then subtract 1 from both sides, and we get that x equals 3. We are going to do a quick check, and you don't actually have to check the answer. You're checking that when you plug that in, it doesn't make a negative under your radical or something that could not be true. So for instance, if I plug in 3, I have 2 times the square root of 4, which is 2 times 2, which does in fact equal 4. So that one is good to go. On this other side, so now square roots, that was kind of starting off with something you have done before. Now we have a cubed root. Same process though. I'm going to add 1 to both sides. So I have the cubed root of 2x minus 9 equals 3. And now since this is a cubed root, I'm going to raise both sides to the cubed power, or the power of 3, so that these cancel out, and I have 2x minus 9 equals 3 cubed, which is 27. And from there, we just go through and solve. So we're going to add 9 to both sides, so 2x equals 36, divide by 2, x equals 18. And if I do my check, when I plug in an 18, I get 36 minus 9, and 36 minus 9 is 27. So that would give me 3 minus 1, which does in fact equal 2. So you don't have to make a big deal out of the check. You're just making sure that your answer works. Okay, so those two were pretty straightforward. We didn't have to do anything fancy. You're just isolating the radical, raise to the reciprocal power, and solve. Now, with this next one, notice I do have the radical already isolated. So when I go to square both sides, because that's a square root, I can't do it individually. I have to do it to the whole side. Remember, you cannot distribute a radical across addition and subtraction. So that means what I have over here is x plus 1 times x plus 1. That's what squaring it means. On the other side, this canceled, and I have 7x plus 15. So foiling this out, is going to give me x squared plus my oi, outer and inner together, will give me 2x. My last term will give me 1. So notice we basically have a quadratic that we want to set equal to 0. So I'm going to subtract 7x from both sides. That gives me negative 5x. I'm going to subtract 15 from both sides. That gives me a negative 14. And then we are going to look to factor this. So if I do my little X-Men, I have a negative 14 and a negative 5. And we want to think about what times what is 14 but adds up, or negative 14 adds up to a negative 5. That would be a negative 7 and a positive 2. And since a is 1, those are the numbers that go into the parenthesis. X minus 7, x plus 2. So we actually end up with two answers. You have x equals a positive 7 or a negative 2, which means we have to check both answers. So when I plug in 7, and what we really care about is, well, let's just go ahead. So if I plug in 7, under the radical I get 49 plus 15. 49 plus 15 is 64. And 64 equals 7 plus 1. So that one is okay. Let's plug in a negative 2. If I plug in a negative 2, I get 15 minus 14, so negative 14 plus 15, which is 1. And that supposedly equals negative 2 plus 1. That is not possible. You can never have a radical with an even power, or even root, equal a negative number. So we cross this out, and there is your only answer. So x equal negative 2 was extraneous. All right. So you can see the benefit then of doing that checking, because it would be wrong to say that that worked. Okay, so notice you had to do a little foiling there, and then you still had a quadratic, so you still had to factor, and then get your two solutions. When you get a problem like this next one, these are probably the hardest problems you will see. Okay, so that's why I gave it the most space. Because you see two radicals, that means you're going to do this process twice in terms of isolating the radical. So how this works is we are going to square both sides. On the left side, I'm going to have to FOIL that out. So what we really have here is square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. That is going to just equal 3 minus x, because we could just have the square cancel the square root on the other side. So when we FOIL this out, the first term is just going to give me x plus 2, because the two radicals will cancel. Then I get to the next term. That is going to be just x plus 2 times 1. My inner term is going to be another, x plus 2 in here. This will be another x plus 2. And then our last term will be plus 1, and this all still equals 3 minus x. So I lined up my like terms here. Also, the 2 and the 1 can be joined together. So I actually have x plus 3 plus 2 of these radicals equals 3 minus x. So we went through the process. We isolated the radical. We, one of them, squared both sides, kind of combined some like terms, which we're about to do, and our goal right now, we still have another radical left, so our goal is to isolate that radical. So the first thing I'm going to do is, let's subtract x from both sides, so that I'll have 2x on that side, and I'm going to subtract 3 from both sides. This will kind of make it maybe a little easier. So I have 2 times the square root of x plus 2 equals 3 minus 3, those are going to go away, but I have a minus 2x. we want to isolate that radical. So we're going to divide both sides by 2. And I'm going to kind of draw a line here. And then continue up here. So I now have x plus 2 equals a negative x. So let's go through. We do want to square both sides. So I square this, in parentheses, square that. So that gives me x plus 2 equals x squared, which again is a quadratic. So we're going to set it equal to 0. So 0 equals x squared minus x minus 2. And then we want to FOIL this. So we look at what times what is negative 2 but adds to a negative 1. That would be a negative 2 and a positive 1. So this will factor into x minus 2, x plus 1, which means my two potential answers are 2 or negative 1, and we want to check. So going back to the very original equation, if I plug in a 2, I'm going to get the square root of 4 plus 1. Does that equal 3 minus 2, which is 1? Well, 2 plus 1, 3 minus 2. And it turns out that 3 does not equal 1. So 2 does not work. Let's check out our negative 1. If I plug in a negative 1, I have 2 minus 1, which is 1, plus 1. Does that equal 3 minus a negative 1? So 3 plus 1, which is 4. So is 1 plus 1 equal to 2? Yes, it is. So our only answer is x equals a negative 1. So you do want to plug them back in, because quite often, especially when you have two answers, there are times when both answers work. There are times when both answers don't work, but there's a lot of times when one answer will work and one answer won't. So you definitely want to check both of them. Okay, now what happens when you have these crazy other powers going on? Well, the process is going to be the same. You isolate wherever the exponent is. So we're going to subtract 2 from both sides. So I have 2x to the 3/4 equals 8. And I want to get rid of that exponent. So I'm going to raise both sides to the reciprocal power, which is 4/3. So these just basically cancel each other out, giving me 2x. On the other side, now we can work this out without a calculator. Remember, you start from the bottom. So this is like taking the cubed root of 8 and raising it to the 4th power. So that's 2 to the 4th, which is 16. And now I can solve for x. We can see that x will equal 8. And if I were to plug it back in, I would have 16, the 2 times 16, so where can I do my check? Let's do it down here, so check. 8 times 2 is 16 to the 3/4, which is 8 plus 2, which is 10, and that works. All right, the next one is x plus 30 to the 1/2. So I'm just going to multiply both sides, raise both sides to the 2nd power, because 2 and 1/2 cancel each other out. That gives me x plus 30 equals x squared. Once again, we have a quadratic. So x squared minus x minus 30. We can factor that. I'm running out of room because the bell just rang. X minus 30. So what is that going to give me? A negative 6 and a positive 5. So x equals 6 or negative 5. And we definitely want to check. If I plug in a negative 5, what happens is I have the square root of 25 equals a negative 5. And that can't happen. So we cross that one out. If I plug in 6, the square root of 36 is 6. That one works. All right. So I hope that was helpful, and I will let you go from there.